In this problem, we are asked to find the asymptotes of the graph of this function 4 minus x divided by 3 plus x. With that information, sketch the graph of the function and then the graph of the derivative. And finally, find the derivative using the definition. Very important, this must be done by the definition. So let's get to it. There are two types of asymptotes that we need to worry about in this problem. The vertical asymptotes and the horizontal asymptotes. There is a third type, the slanted asymptotes, but we don't need to worry about that in this problem. So to find vertical asymptotes, we just need to find zeros of the denominator. Okay, and to find the horizontal asymptotes, we need to find the limits as x tends to plus or minus infinity of f of x. And if that is a constant, then y equals L is a horizontal asymptote. All right, so in this case, we have f of x, which is 4 minus x divided by 3 plus x. And that gives a vertical asymptote, which is x equals -3. And then the limit as x tends to infinity, 4 minus x over 3 plus x. This is the same as x to infinity of 4 divided by x minus 1 divided by 3 divided by x plus 1. Now it's clear 4 divided by x or 3 divided by x, those are going to disappear. They go to 0, so I get -1. And the limit as x tends to negative infinity, well, this is the same. So x tends to negative infinity, 4 over x minus 1 divided by 3 over x plus 1. Now 4 over x and 3 over x are negative numbers, but they are getting smaller and smaller and smaller. And at some point they are going to disappear, to vanish. They don't matter. So we still get -1. So we get y equal 1 as a horizontal asymptote, both to the right and to the left. All right, so now we can draw our axis here. There we go. Let me move this a little bit to the, there we go. We have an asymptote that x equals 3. Let's say here, sorry, -3. This is the horizontal asymptote, the vertical asymptote. And then we have the horizontal one at y equals -1. I just realized I wrote y equal 1, but it's -1. There we go. Okay. So the function is going to approach the asymptotes. Okay, from one of the two sides. We need to figure out which side. Okay, so let's do this. It cannot be from both sides. It can be from, well, we need to figure out. So when I look at the function 4 minus x divided by 3 plus x, for example, if x is a positive number, 3 plus x is going to be, actually, if x is bigger than -3, then x plus 3 is positive. Okay, so on the right of the asymptote, I know that the denominator is positive. Now notice 4 minus x equals 0. That means that x must be equal to 0, to 4. So that means that here at x equals 4, the function has a root. Okay. And then with this information, now it's clear, right? We have an asymptote here. The function needs to go either up or down, and it has to go through to the right. So my guess would be that the function is going to look something like this. Correct? Then we can erase the other guidelines. Okay. And now my guess is that the function on the other side is going to look something like this. Okay. Now, once you have this guess, you should confirm it, just seeing if the function, if the signs are correct. Okay, this is what we can do at this time. So for example, if I take x less than -3, I have that 4 minus x is going to be at least as big as 7, okay, because it's 4 minus -3. And then the denominator is going to be a negative number. For example, if I take x something strictly less than -3, like -4, for example, I get 3 plus x would be -1, -2, and so on. So moral of the story, positive numerator, negative denominator, negative function. So we are, this is good. Okay, we are on the right place. Now, if I look to the right side, when x is bigger than 4, I have a positive denominator and a negative numerator. So the function is negative, that's correct. Okay, but if I'm on the right of 4, then I have a number x that is less than 4, so the numerator is positive and the denominator is positive, so it makes sense that the function is like this, positive. Okay, so this is a good sketch. Now, this was the part A. So for part B, we need to use this sketch to sketch the graph of the derivative. So let's copy the axis. Here it may help to zoom out. And now we need to notice something here. So when we want to sketch the derivative, so this was my function f. So now I want the derivative. That's for part B. Let's look at the derivative. So the derivative is, the interpretation is the slope, right? So we can put some tangents here. See how the derivative looks. But you see, it's clear that the derivative is going to be negative here on the left, because all the slopes are pointing down. Okay, and there are two more things that we can say as we go towards the left. What happens to the derivative, to the slope? It flattens. Okay, so we can say that the limit of f prime as x tends to -infinity is 0. So funny enough, the derivative has a horizontal asymptote at y equals 0. Okay, as we go towards -infinity. And then as we approach here x equals -3, we are going to have more and more vertical slopes. Okay, that means the limit as x tends to -3 from the left, of the derivative must be negative infinity. Okay, means a completely vertical slope, but coming from the negative. So we are more and more decreasing slopes. Now, if I look at the right-hand side, here, how are these slopes? So these slopes are also negative. Okay, they are also negative. And again, a similar thing happens. We have that the slopes flatten out as we move towards the right. Okay, so we have that the limit of f prime is 0 as x tends to infinity. And if we look at where they are coming from, they come from vertical. Okay, so they start completely vertical and then they start growing up from negative infinity. They start growing up all the way to 0. So that means that the limit of the derivative as we approach negative 3 from the right is going to be also negative infinity. Okay, and this is all the information we need. With this information, let's copy this referential. There we go. So we have a negative function. Okay, so it's going to be living on the bottom half of this graph. And we have a function that needs to approach 0 asymptotically. Okay, so we have the horizontal asymptote. And then I also found that it has a vertical asymptote at negative 3. And it's negative infinity from both sides. And that's all the information we need. Okay, the guess here would be for something like this. There we go. And then on the other side, something like this. And there is, based on the graph, that's all we can say. There is one more thing that we could say here. Is where is this crossing? Okay, but for that we need the formula. But we are going to find the formula in the part C, so we can double check what is this number. I will tell you what the number is, then we can check. So this number is negative 7/9. Okay, if you are wondering how I found this out, you can do the derivative, or we can do it by the definition as the problem is asking. So let's do that. Here, so C, we have f of x, that is 4 minus x divided by 3 plus x. Remember, if the problem is saying to find the derivative using the definition, you need to do the definition. If you do using the rules of differentiation, then you don't get points for that, okay? So what is the definition of derivative? Limit as h to 0 of fx plus h minus f of x divided by h. Very important to write down the limit. Okay, sometimes we don't write this, then it's incorrect. Okay, so we need to write the limit every time. So limit h to 0, and then evaluate the function at x plus h. So what we are going to do, where we had x, we are going to plug in parentheses x plus h. Divided by 3 plus x plus 8 minus 4 minus x, 3 plus x, divided by h. And here, at this point, the only thing we can do is to simplify. You see, we have a difference of two fractions. So we need to get a common denominator, do the computation and see what happens. Remember, in this type of problems, there is always a lot of simplification. If nothing simplifies, then we should go back because something is wrong. Okay, so 3 plus x, and then everything divided by h. All right, so this gives limit as h to 0. This is 8 times 3 plus x plus 8, 3 plus x, and then the numerator, this is going to be 12 plus 4x minus 3x minus 3h minus x squared minus xh minus 12 plus 3x minus 4x minus 4h plus x squared plus xh. All right, and that's it. Now let's see what we got. There we go. So we have 12, negative 12. We have, well, let's use the red, 3x, negative 3x. We have x squared, negative x squared, x minus 8, negative x h, 4x, negative 4x, and that's it. We are left, that was a lot of simplification. So we are left with minus 7h divided by 8, 3 plus x plus 8, 3 plus x. Okay, so the 8 simplifies, and the limit we can do now is negative 7 divided by 3 plus x squared. And this is the formula for the derivative. Okay, notice when I do x equals 0, f prime of 0 is 7 divided by 3 squared, that's negative 7 over 9, which is the number I said before. Okay, that's the crossing with the y-axis of the derivative. And actually, this makes all the sense because we have a negative function, negative 7 divided by a square, that's negative. Okay, so clearly what we got was a negative function, and it has a vertical asymptote at x equals negative 3 because the denominator becomes 0 for that value of x. Okay, if we wish, we can always, this doesn't answer the question and it's work on the side, not for grade, but we can always compute the derivative using the quotient rule to see if we did correct. So we have 4 minus x prime times 3 plus x minus 4 minus x, 3 plus x prime divided by 3 plus x squared. Remember, this is the formula for the quotient. So we have minus 3 plus x minus 4 minus x divided by 3 plus x squared. And here, clearly, this is negative 7 divided by 3 plus x squared. So we are good. We were right with our derivative that we found using the definition.